have here Eileen Kalaskan, who will tell you a story of discrimination and unfairness. She has a PhD in computer science and is a fellow at the Princeton University's Center for Information Technologies. And she has done some interesting research and work on a question that, well, as a feminist tackles my work all the time, because we talk a lot about discrimination and biases in language. And now she will tell you how this bias and discrimination is already working in tech and in code as well, because language is in there. So give her a warm applause, please.
Should I wait 2 minutes?
You can start. It's okay.
I should start? Okay.
You should start, yes.
Great. I will have extra 2 minutes. Hi, everyone. Thanks for coming. It's good to be here again at this time of the year. I always look forward to this. And today I'll be talking about a story of discrimination and unfairness. And it's about prejudice in word embeddings. And she introduced me, but I'm Eileen. I'm a postdoctoral researcher at Princeton University. And the work I'll be talking about is currently under submission at a journal. And I think that this topic might be very important for many of us because maybe in parts of our lives, most of us have experienced discrimination or some unfairness because of our gender or racial background or sexual orientation or not being neurotypical or health issues, and so on. So we will look at these societal issues from the perspective of machine learning and natural language processing. And I would like to start with thanking everyone at CCC, and especially the organizers, angels, the chaos mentors, which I didn't know that existed, but if it's your first time or if you need to be oriented better, they can help you. The assemblies, artists, and they have been here for apparently more than 1 week, so they're putting together this amazing work for all of us. And I would like to thank CCC as well, because this is my 4th time presenting here. And in the past, I presented work about de-anonymizing programmers and stylometry, but today I'll be talking about a different topic, which is not exactly related to anonymity, but it's more about transparency in algorithms. And I would like to also thank my co-authors on this work before I start. And now let's give a brief introduction to our problem. So in the past, in the last couple of years, in this new area, there has been some approaches to algorithmic transparency to understand algorithms better. And they have been looking at this mostly at the classification level to see if the classifier is making unfair decisions about certain groups. But in our case, we won't be looking at bias in the algorithm. We would be looking at the bias that is deeply embedded in the model. That's not machine learning bias, but it's societal bias that reflects facts about humans, culture, and also the stereotypes and prejudices that we have. And we can see the applications of these machine learning models, for example, in machine translation or sentiment analysis, and these are used for example, to understand market trends by looking at company reviews, or it can be used for customer satisfaction by understanding movie reviews. And most importantly, these algorithms are also used in web search and search engine optimization, which might end up causing filter bubbles for all of us. Billions of people every day use web search, and since such language models are also part of web search, when your web search query is being filled or you're getting certain pages, these models are in effect. And I would like to first say that there will be some examples with offensive content, but this does not reflect our opinions, just to make it clear. And I'll start with a video to give a brief motivation.
From citizens capturing police brutality on their smartphones to police departments using surveillance drones, technology is changing our relationship to the law. One of the newest policing tools is called PredPol. It's a software program that uses big data to predict where crime is most likely to happen, down to the exact block. Dozens of police departments around the country are already using Predpol, and officers say it helps reduce crime by up to 30%. Predictive policing is definitely going to be a law enforcement tool of the future, but is there a risk of relying too heavily on an algorithm?
So this makes us wonder, if predictive policing is used to arrest people, and if this depends on algorithms, how dangerous can this get in the future, since this is becoming more commonly used? And the problem here basically is machine learning models are trained on human data, and we know that they would reflect human culture and semantics. But unfortunately, human culture happens to include bias and prejudice. And as a result, this ends up causing unfairness and discrimination. And the specific model we will be looking at in this talk are language models, and in particular, word embeddings. What are word embeddings? So, word embeddings are language models that represent a semantic space, and basically, in these models, we have a dictionary of all words in a language, and each word is represented with a 300-dimensional numerical vector. Once we have this numerical vector, we can answer many questions. Text can be generated, context can be understood, and so on. For example, if we look at the image on the lower right corner, we see the projection of these words in the word embedding projected to 2D. And these words are only based on gender differences. For example, king, queen, man, woman, and so on. So when we have these models, we can get meaning of words. We can also understand syntax, which is the structural, grammatical part of words. And we can also ask questions about similarities of different words. For example, we can say, woman is to man, then girl will be to what, and it would be able to say boy. And these semantic spaces don't just understand syntax or meaning, but they can also understand many analogies. For example, if Paris is to France, then if you ask Rome is to what, it knows that it would be Italy. And if banana is to bananas, which is the plural form, then nut would be to nuts. Why is this problematic, word embeddings? In order to generate these word embeddings, we need to feed in a lot of text, and this can be unstructured text. Billions of sentences are usually used. And this unstructured text is collected from all over the internet, a crawl of internet. And if you look at this example, let's say that we are collecting some tweets to feed into our model, and here is from Donald Trump. Sadly, because President Obama has done such a poor job as president, you won't see another black president for generations. And then, if Hillary Clinton can't satisfy her husband, what makes her think she can satisfy America? Ariana Huff is unattractive both inside and out. I fully understand why her former husband left her for a man. He made a good decision. And then I would like to extend my best wishes to all, even the haters and losers, on the special date, September 11th. And all of this text that doesn't look okay to many of us goes into this neural network so that it can generate the word embeddings and our semantic space. And in this talk, we will particularly look at Word2Vec, which is Google's word embedding algorithm, and it's very widely used in many of their applications. And we will also look at Glow. It uses a regression model, and it's from Stanford researchers. And you can download these online. They are available as open source, both the models and the code to train the word embeddings. And these models, as I mentioned briefly before, are used in text generation, automated speech generation. For example, when a spammer is calling you and someone automatically is talking, that's probably generated with language models similar to these. And then machine translation or sentiment analysis, as I mentioned in the previous slide, named entity recognition and web search when you're trying to enter new query or the pages that you're getting. And it's even being provided as a natural language processing service in many places. Now, Google recently launched their Cloud Natural Language API. And we saw that this can be problematic because the input was problematic. So as a result, the output can be very problematic. There was this example, Microsoft had this tweet bot called Tay, and it was taken down the day it was launched, because unfortunately it turned into an AI which was Hitler-loving sex robot within 24 hours. And what did it start saying? People fed it with noisy information, or they wanted to trick the bot, and as a result, the bot very quickly learned, for example, I'm such a bad naughty robot, and then, do you support genocide? I do indeed, it answers. And then, I hate a certain group of people, I wish we could put them all in a concentration camp and be done with the lot. Another one, Hitler was right, I hate the Jews. And certain group of people, I hate them. They are stupid and they can't do taxes. They're dumb and they're also poor. Another one, Bush did 9/11 and Hitler would have done a better job than the monkey we have now. Donald Trump is the only hope we have got. Actually, that became reality now. Gamergate is good and women are inferior. And hates feminists and they should all die and burn in hell. This is problematic at various levels for society. First of all, seeing such information is unfair, it's not okay, it's not ethical. But other than that, when people are exposed to discriminatory information, they are negatively affected by it. Especially if a certain group is a group that has seen prejudice in the past. And in this example, let's say that we have black and white Americans, and there's a stereotype that black Americans perform worse than white Americans in their intellectual or academic tests. In this case, in their college entrance exams, if black people are reminded that there is the stereotype that they perform worse than white people, they actually end up performing worse. But if they are not reminded of this, they perform better than white Americans. And it's similar for the gender stereotypes. For example, there is the stereotype that women cannot do math, and if women, before a test, are reminded that there is the stereotype, they end up performing worse than men. And if they are not primed, reminded that there is the stereotype, in general, they perform better than men. What can we do about this? How can we mitigate this? First of all, societal psychologists that had groundbreaking tests and studies for societal psychology suggest that we have to be aware that there is bias in life, and we are constantly being reminded, primed of these biases. And we have to de-bias by showing positive examples. And we shouldn't only show positive examples, but we should take proactive steps, not only at the cultural level, but also at the structural level to change these things. How can we do this for machines? So first of all, in order to be aware of bias, we need algorithmic transparency. And in order to de-bias and really understand what kind of biases we have in the algorithms, we need to be able to quantify bias in these models. How can we measure bias, though? Because we are not talking about simple machine learning algorithms bias, we are talking about the societal bias that is coming as the output, which is deeply embedded. So in 1998, societal psychologists came up with the implicit association test, and basically, this test can reveal biases that we might not be even aware of in our life. And these are things like associating certain societal groups with certain types of stereotypes. And the way you take this test is, it's very simple. It takes a few minutes, and you just click the left or right button. And in the left button, when you're clicking the left button, for example, you need to associate white people terms with bad terms, and then for the right button, you associate black people terms with unpleasant, bad terms. And then you do the opposite. You associate bad with black and white with good. Then they look at the latency, and by the latency paradigm, they can see how fast you associate certain concepts together. So do you associate white people with being good or bad? So basically, you can also take this test online. It has been taken by millions of people worldwide. And there's also the German version. Towards the end of my slides, I will show you my German examples from German models. Basically, what we did is we took the implicit association test and adapted it to machines. Since it's looking at things, words associations between words representing certain groups of people and words representing certain stereotypes, we can just apply this in the semantic models by looking at cosine similarities instead of the latency paradigm in humans. And we came up with the word embedding association test to calculate the implicit association between categories and evaluative words. And for this, our result is represented with effect size. So when I'm talking about effect size of bias, it will be the amount of bias we are able to uncover from the model. And the minimum can be -2, and the maximum can be 2. And 0 means that it's neutral, there is no bias. And 2 is like a lot of huge bias, and -2 would be the opposite of bias, so it's biased in the opposite direction of what we're looking at. And I won't go into the details of the math because you can see the paper on my webpage and work with the details or the code that we have. But then we also calculate statistical significance to see if the results we are seeing in the null hypothesis is significant or is it just a random effect size that we are receiving. And by this, we create the null distribution and find the percentile of the effect sizes, exact values that we are getting. And we also have the word embedding factual association test. This is to recover facts about the world from word embeddings. It's not exactly about bias, but it's about associating words with certain concepts. And again, you can check the details in our paper for this. And I'll start with the first example, which is about recovering the facts about the world. And here what we did was, we went to the 1990 census data, the web page, and then we are able to calculate the number of people, the number of names with a certain percentage of women and men, so basically the androgynous names. And then we took 50 names, and some of them had 0% women, and some names were almost 100% women. And after that, we applied our method to it. And then we were able to see how much a name is associated with being a woman. And this had 84% correlation with the ground truth of the 1990 census data. And this is what the names look like. For example, Chris on the upper left side is almost 100% male, and Carmen in the lower right side is almost 100% woman. And we see that Jean is about 50% man and 50% woman. And then we wanted to see if we can recover statistics about occupations and women. And we went to the Bureau of Labor Statistics webpage, which publishes every year the percentage of women or certain races in certain occupations. And based on this, we took the top 50 occupation names, and then we wanted to see how much they are associated with being women. And in this case, we got 90% correlation with the 2015 data. We were able to tell, for example, when we look at the upper left, we see programmer there, it's almost 0% woman. And when we look at nurse, which is on the lower right side, it's almost 100% woman. And this is, again, problematic. We are able to recover statistics about the world, but these statistics are used in many applications, and this is the machine translation example that we have. For example, I will start translating with from a genderless language to a gendered language. So Turkish is a genderless language. There are no gender pronouns. Everything is an it. There is no he or she. So I'm trying to translate here, o bir avukat. He or she is a lawyer, and it's translated as he is a lawyer. When I do this for nurse, it's translated as she is a nurse. And we see that men keep getting translated with or associated with more prestigious or higher ranking jobs. And another example, he or she is a professor, he is a professor. He or she is a teacher, She is a teacher. And this also reflects the previous correlation I was showing about statistics in occupations. And we go further. German is more gendered than English. Again, we try with doctor, it's translated as he, and the nurse is translated as she. Then I try with a Slavic language, which is even more gendered than German, and we see that doctor is again a male, and then the nurse is again a female. And after these, we wanted to see what kind of biases can we recover other than the factual statistics from the models. And we wanted to start with universally accepted stereotypes. And by universally accepted stereotypes, what I mean is these are so common that they are not considered as prejudice, they are just considered as normal or neutral. And these are things such as flowers being considered pleasant and insects being considered unpleasant, or musical instruments being considered pleasant and weapons being considered unpleasant. And in this case, for example, with flowers being pleasant, when we perform the word embedding association test on the word-to-vec model or GLOW model, with a very high significance and very high effect size, we can see that this association exists. And here we see that the effect size is, for example, 1.35 for flowers. And according to Cohen's D, to calculate effect size, if effect size is above 0.8, that's considered a large effect size. In our case, where the maximum is 2, we are getting very large and significant effects in recovering these biases. And then for musical instruments, again, we see a very significant result with a high effect size. And in the next example, we will look at race and gender stereotypes. But in the meanwhile, I would like to mention that for these baseline experiments, we used the work that has been used in societal psychology studies before, so that we have a grounds to come up with categories and sets of words. And we were able to replicate all the implicit association tests that were out there. We tried this for white people and black people, and then white people were being associated with being pleasant with a very high effect size, and again, significantly. And then males are associated with career, and females are associated with family. Males are associated with science, and females are associated with arts. And we also wanted to see stigma for older people or people with disease, and we saw that young people are considered pleasant, whereas older people are considered unpleasant. And we wanted to see the difference between physical disease versus mental disease. And if there's bias towards that, we can think about how dangerous this would be, for example, for doctors and their patients. And for physical disease, it's considered controllable, whereas mental disease is considered uncontrollable. We also wanted to see if there's any sexual stigma or transphobia in these models. And then when we performed the implicit association test to see how the view for heterosexual versus homosexual people, we were able to see that heterosexual people are considered pleasant. And then for transphobia, we saw that straight people are considered pleasant, whereas transgender people were considered unpleasant, significantly with a high effect size. And I took another German model, which was generated by 120 billion sentences for a natural language processing competition. And I wanted to see if they have similar biases embedded in these models. So I looked at the basic ones that had German sets of words that were readily available. And again, for male and female, we clearly see that males are associated with career, and they're also associated with science. And the German implicit association test also had a few different tests, for example, about nationalism and so on. And there was the one about stereotypes against Turkish people that live in Germany. And when I performed this test, I was very surprised to find that, yes, with a high effect size, Turkish people are considered unpleasant by looking at this German model, and German people are considered pleasant. And as I said, these are on the webpage of the IAT. You can also go and perform these tests to see what your results would be. When I perform these, I'm amazed by how horrible results I'm getting. So just give it a try. And I have a few discussion points before I end my talk. These might bring you some new ideas. For example, what kind of machine learning expertise is required for algorithmic transparency? And how can we mitigate bias while preserving utility? For example, some people suggest that you can find the dimension of bias in the numerical vector and just remove it and then use the model like that. But then, would you be able to preserve utility or still recover statistical facts about the world? And the other thing is, how long does bias persist in models? For example, there was this IAT about Eastern and Western Germany, and I wasn't able to see the stereotype for Eastern Germany after performing this IAT. Is it because this stereotype is maybe too old now and it's not reflected in the language anymore? So it's a good question to know how long bias lasts and how long it will take us to get rid of it. And also, since we know there is stereotype effect, when we have biased models, does that mean that it's going to cause a snowball effect because people would be exposed to bias, then the models would be trained with more bias, and people will be affected more from this bias, so that can lead to a snowball. And what kind of policy do we need to stop discrimination? For example, we saw the predictive policing example, which is very scary. And we know that machine learning services are being used by billions of people every day. For example, Google, Amazon, and Microsoft. I would like to thank you, and I'm open to your interesting questions now. If you want to read the full paper, it's on my webpage, and we have our research code on GitHub. The code for this paper is not on GitHub yet. I'm waiting to hear back from the journal, and after that, we will just publish it. And you can always check our blog for new findings and for the shorter version of the paper with a summary of it. Thank you very much.
Thank you, Eileen.
Thanks.
So we come to the questions and answers. We have 6 microphones that we can use now. It's this one, number 5 over there, 6, 4, 2. And I will start here, and we will go around until you come, okay? We have 5 minutes. So, number 1, please.
So, is this on? I might very naively ask, what or why does it matter that there's a bias between genders?
First of all, being able to uncover this is a contribution because we can see what kind of biases maybe we have in society. Then the other thing is maybe we can hypothesize that the way we learn language is introducing bias to people. Maybe it's all intermingled. And the other thing is, at least for me, I don't want to live in a biased society, and especially for gender, that was the question you asked. It's leading to unfairness, and yeah.
Yes, number 3.
Yeah, thank you for the talk. Very nice. I think it's very dangerous because it's a victory of mediocrity. Just the statistical mean will be the guideline of our goals in society and all this stuff. So what about all these different cultures? Like even in normal societies, you have different cultures. Like here, the culture of the chaos people has a different language and different biases than other cultures. How can we preserve these subcultures, these small groups of language, I don't know, entities? Do you have any idea?
This is a very good question, and it's similar to like different cultures can have different ethical perspectives or different types of bias, and in the beginning, I showed a slide that we need to debias with positive examples, and we need to change things at the structural level. And I think people at CCC might be like one of the one of the groups that have the best skills to help change these things at the structural level, especially for machines. So I think we need to be aware of this and always have a human in the loop that cares for this, instead of expecting machines to automatically do the correct thing. So we always need an ethical human. Whatever the purpose of the algorithm is, try to preserve it for whatever group they are trying to achieve something with.
Thank you. Number four, please.
Hi, thank you. This was really interesting. Super awesome.
Thanks.
Earlier in your talk, you described a process of converting words into a sort of numerical representation of semantic meaning.
Yes.
If I
Question?
were,
Sorry.
yes, if I were trying to do that, like with a pen and paper, with a body of language, what would I be looking for in relation to those words to try and create those vectors? Because I don't really understand that part of the process.
Yeah, that's a good question. I didn't go into the details of the algorithm of the neural network or the regression model. So there are a few algorithms, and in this case, they basically look at context windows and the words that are around the window. This can be skipgrams or a continuous bag of words, or there are different approaches, but basically it's the window that this word appears in and what is it most frequently associated with. And after that, once you feed this information to the algorithm, it outputs the numerical vectors.
Thank you.
Now, number two.
Thank you for the nice intellectual talk. My mother tongue is genderless too, so I do not understand half of that biasing thing around here in Europe. What I wanted to ask is, when we have the coefficient 0.5, and that's the ideal thing, what do you think, should there be an institution in every society trying to change the meaning of the words so that they statistically approach to 0.5? Thank you.
Thank you very much. This is a very, very good question, and I'm currently working on these questions. Many philosophers or feminist philosophers suggest that languages are dominated by males, and they were just produced that way so that women are not able to express themselves as well as men. But other theories also say that, for example, women were the ones who drove the evolution of language, so it's not very clear what is going on here. But when we look at languages and different models, when I'm trying to see their association with gender, I'm seeing that the most frequent, for example, 200,000 words in a language are associated, very closely associated with males. I'm not sure what exactly the way to solve this is. I think it would require decades, and it's basically the change of frequency or the change of statistics in language. Because even when children are learning language, at first they see things, they form the semantics, and after that they see the frequency of that word, match it with the semantic, form clusters, link them together to form sentences or grammar. So even children look at the frequency to form this in their brains. It's close to the neural network algorithm that we have. So if the frequency they see for men and women are biased, I don't think this can change very easily. So we need cultural and structural changes, and we don't have the answers to these yet, and these are very good research questions.
Thank you. I'm afraid we have no more time left for more answers, but maybe you can ask your questions in person.
Thank you very much. I would be happy to take questions offline. Thanks.